Right now, as you watch this video, a rock the size of a small mountain is hurtling past Earth at nearly 20,000 miles per hour. It is called 1997 NC1. It is roughly 1 kilometer wide, about the length of 10 football fields. It is 50 to 60 times larger than the Chelyabinsk meteor that exploded over Russia in 2013, shattering windows in 6 cities and sending 1,500 people to hospitals. That one was 20 meters wide, and nobody saw it coming. This one is a kilometer. On June 27, 2026, asteroid 1997 NC1 will pass Earth at a distance of approximately 2.4 million kilometers, about 6.5 times farther than the Moon. That might sound safe, and it is. There is zero chance of impact during this flyby. But on the scale of the solar system, this is a near miss. NASA classifies any asteroid larger than 140 meters that passes within 7.5 million kilometers of Earth as a potentially hazardous asteroid. 1997 NC1 is 7 times larger than that threshold, and this is its closest approach to Earth in the entire 21st century. The last time an asteroid this big came this close was in January 2022. Before that, you have to go back to February 1976, and that one passed completely unnoticed because we did not have the technology to. So what would happen if an asteroid like 1997 NC1 actually hit the Earth? The answer is terrifying. A 1-kilometer asteroid would punch through the atmosphere completely intact. It would strike the ground at roughly 32,000 kilometers per hour, instantly vaporizing itself and everything at the impact site. The explosion would carve a crater 10 to 15 kilometers wide and over 1.6 kilometers deep. If it landed near a city, the collision would level concrete buildings. The shockwave would strip the landscape bare for hundreds of kilometers around the impact zone. It would launch billions of tons of dust and debris into the atmosphere, blocking sunlight and triggering what scientists call an impact winter, a global cooling event that could devastate agriculture and trigger mass starvation. This is not speculation. This is physics. And it has happened before.
66 million years ago, an asteroid, roughly 10 kilometers wide, struck what is now the Yucatan Peninsula in Mexico. It created the Chicxulub crater, 180 kilometers across. The impact released energy equivalent to 10 billion nuclear bombs. It triggered earthquakes, tsunamis, wildfires that swept across continents, and an impact winter that lasted years. It wiped out 75% of all species on Earth, including every non-avian dinosaur. One rock, one impact, and the dominant life forms on the planet were gone. Now, 1997 NC1 is not 10 kilometers wide, it is 1 kilometer. But even at that size, the consequences of an impact would be catastrophic on a regional to continental scale. And the uncomfortable truth is that we have not been watching the sky for very long. Asteroid 1997 NC1 was discovered on July 5, 1997, less than 30 years ago, by the Near-Earth Asteroid Tracking System at Haleakala Observatory in Hawaii. Before that, we did not know it existed. As of today, NASA tracks nearly 42,000 near-Earth objects. Of those, 2,539 are classified as potentially hazardous. But there are an estimated 25,000 near-Earth asteroids larger than 140 meters that we have not found yet. They are out there, we just have not spotted them. And the Chelyabinsk event in 2013 proved how dangerous that gap can be. That asteroid came from the direction of the sun, a blind spot for ground-based telescopes. Nobody saw it until it exploded in the atmosphere. If you find this both fascinating and terrifying, subscribe to the Odd Vault and hit the bell, because the story of how we are preparing to defend the planet is even more remarkable. In September 2022, NASA did something unprecedented. It deliberately crashed a spacecraft into an asteroid. The mission was called DART, the Double Asteroid Redirection Test. The target was Dimorphos, a small moonlet orbiting a larger asteroid called Didymos. The impact successfully changed Dimorphos's orbit, shortening its orbital period by 33 minutes. It was the first time in history that humans had intentionally altered the trajectory of a celestial body. It was proof of concept, evidence that if we detect a dangerous asteroid early enough, we might be able to push it off course before it reaches us. But DART only works if we see the threat coming, and that is the biggest challenge in planetary defense: detection. The earlier we find a dangerous asteroid, the more time we have to act. A small nudge applied years in advance can shift an asteroid's path by thousands of kilometers. But the same asteroid discovered weeks before impact leaves almost no options. NASA and ESA are building next-generation detection systems. The NEO Surveyor Space Telescope, designed specifically to find asteroids from space, is expected to launch in the coming years. It will scan the sky in infrared, detecting dark asteroids that reflect very little sunlight, the ones that are hardest to find from Earth. And there is one asteroid that the entire scientific community is watching very closely. Its name is Apophis. It is approximately 370 meters wide, about the size of the Empire State Building. On April 13, 2029, Apophis will pass within just 32,000 kilometers of Earth. That is closer than our geostationary satellites. It will be visible to the naked eye, a point of light drifting across the sky, closer to Earth than any asteroid of its size has come in recorded history. Current calculations confirm that Apophis will not hit Earth in 2029, or in 2036, or for at least the next 100 years. But its proximity is a stark reminder of how crowded our cosmic neighborhood really is. There are currently 872 known near-Earth asteroids larger than 1 kilometer. Most of their orbits are well understood, but most is not all. And asteroids are not the only threat. Long-period comets, which come from the outer reaches of the solar system on orbits that take thousands of years, can appear with very little warning. Some of them are large enough to cause extinction-level events, and we have almost no way to detect them until they are already close. The asteroid passing Earth today is a reminder, not a threat, a reminder, that we live on a small, fragile rock in a vast and sometimes violent cosmos. That the same laws of physics that keep us orbiting the sun also send other rocks hurtling through our neighborhood at 20,000 miles per hour. And that the only thing standing between us and the fate of the dinosaurs is our ability to watch the sky, and our willingness to take what we see seriously. Today, 1997 NC1 will pass safely. Tomorrow, the next asteroid begins its approach. And somewhere out there, one we have not found yet is already on its way. This has been The Odd Vault. If this unlocked something in your mind, subscribe, because we open a new vault every week. What they didn't tell you, we will.